Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to get the inverse of a function. Alright.
And here are the steps in finding the inverse of a function. So first step is we need to replace our f of x with y, or we replace our function notation to the variable y. Second step is we're going to interchange the variable x and y. Third step is for us to solve for the new value of y. So we will isolate the variable y and place it in one side of our equation. Then after isolating the variable y, we will replace it with the inverse function notation. Okay, to check if we got the correct inverse function, we will do the composition of the function and the inverse of that function. And the answer should be equal to x. And now let's have some examples in finding the inverse of a function. Alright, okay, let's have our first example. For example, we're given a set of ordered pairs 1, 2, 3, 4, 5, 6, and 7, 8. Now to get the inverse of this function is we're just going to interchange the x coordinate and the y coordinate. So our inverse of this set of ordered pairs will be 2, 1, 4, 3, 6, 5, and 8, 7. Just take note, we will just interchange the values of x and y. Let's have another example. So, for example, we're given another set of ordered pairs, and to get the inverse of this function, we will just interchange our x coordinate and our y coordinate. So we will have our inverse function, negative 6, negative 1, negative 4, 2, 9, 5, and 1, 1. Alright. Next, let's have another example. For example, we have f of x is equal to x minus 8. Let's get the inverse function of f of x. So first step is for us to change our function notation to the variable y. Then, second step is for us to interchange our x and y. So we will have x is equal to y minus 8. Then we solve for the value of y. So let's transfer negative 8 to the other side. Changing the sign, we will have x plus 8 is equal to y. Then let's apply symmetric property. By changing their position, we will have y is equal to x plus 8. Now that we isolated the variable y, we can now change y to the inverse function notation. So we will have the inverse of f of x is equal to x plus 8. Alright, okay, let's have another example. So for example, we're going to get the inverse function of f of x is equal to 2x plus 5. So first step is for us to change the function notation to the variable y. So we will have y is equal to 2x plus 5. Then we interchange the variable x and y. So we will have x is equal to 2y plus 5. Next, we will solve for the value of y. So let's transpose positive 5 to the other side of the equation. We will have x minus 5 is equal to 2y. Then let's divide both sides by 2. We will have x minus 5 all over 2 is equal to y. So let's apply symmetric property so that we interchange their position. We will have y is equal to x minus 5 all over 2. Now that y is isolated, we can now change it to its inverse function notation. So our final answer will be the inverse of f of x is equal to x minus 5 all over 2. Alright, okay, let's have another example. So for example, we're going to get the inverse function of f of x is equal to the square root of x minus 2. So first step is for us to change the function notation to the variable y. So we will have y is equal to the square root of x minus 2. Then, we interchange our x and y. So we will have x is equal to the square root of y minus 2. Then after that, let's solve for the value of y. So let's isolate y by getting the square of both sides. So we square both sides, we will have x squared is equal to y minus 2. Let's transpose negative 2 to the other side of the equation. Let's change the sign, so we have x squared plus 2 is equal to y. Then, let's apply symmetric property. Y is equal to x squared plus 2. Then, after isolating the variable y, we can now change it to the inverse function notation. So we will have the inverse of f of x is equal to x squared plus 2. Alright. Okay, let's have our last example for today. So for example, we're going to get the inverse of f of x is equal to x plus 2 all over x minus 3. So first step is for us to change our function notation to variable y. Then after that, we will interchange our x and y. So we will have x is equal to y plus 2 all over y minus 3. Third step is for us to isolate our variable y. To isolate our variable y, we need to multiply both sides by our denominator y minus 3. Doing that, we can cancel y minus 3 and y minus 3. Then let's apply distributive property. Let's multiply x and the quantity y minus 3. So we will have xy minus 3x is equal to y plus 2. Since we have two variable y in this equation, let's isolate all the terms with the variable y. So let's place all the variable y in one side of our equation. So let's transpose. We will have xy minus y is equal to 3x plus 2. We also transpose negative 3x to the other side of the equation. Now that we isolated all the terms with variable y, let's apply factoring. Let's factor out the variable y. So we will have y times the quantity x minus 1 is equal to 3x plus 2. Then we divide both sides by x minus 1. So we can cancel the factor x minus 1. So we will have y is equal to 3x plus 2 all over x minus 1. Now that we isolated our variable y, we can now change variable y to its inverse function notation. So we have our final answer. The inverse of f of x is equal to 3x plus 2 all over x minus 1. Alright.
Now that you already know how to get the inverse of a function, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace!